We have Mr. Naga Bharat Daka. He is a co-founder of Skyroot Aerospace, an IIT alumnus. Skyroot co-founders, initially they were working in ISRO, and they have started their own, what you call as startups with the Vikram series of launch vehicles. Yes, Mr. Bharat, would like to get your comments on the topic that we are discussing. Also, the various technologies that you are using in realizing the rocket parts like the 3D printing and then the semi-cryo option and the economics behind that. Over to Mr. Bharat.
Hello all. Hello all. First of all, thank you Unikishan sir and Vinod sir for giving context on what it takes to make the cost of space access or reduce the cost of space access when it comes to innovations that we need to do in the existing launch solutions we have. And I'm Bharat. I'm one of the co-founder of Skyroot Aerospace. We are designing and developing a small launch vehicle that can carry up to a few hundreds of kilograms to low Earth orbit. And with a similar objective of the key objective would be to lower the cost from the compared to the current existing solutions that are already available internationally. So to do that, a few of the key configuration or the design innovations we are doing with respect to the kind of raw material or components we use or the manufacturing process is something I'd like to share. So our launch vehicle is a fully carbon composite launch vehicle, which makes it very light and highly efficient for the lift-off weight to the payload ratio. And also we are using, to reduce the cost of avionics, we'll be using mostly 90% industrial grade components and qualifying the module level subsystems for the mill grade specifications. And it's been a proven approach with even small satellites that have been going through LEO and having multiple year lives. And one of the other innovations we can make to reduce not only the cost, but also the timeline to launch. So because it's been around four years since we started, and our target is to reach orbit within 5 years. And next year is one of the most crucial year for us. So to reduce the timeline for launch, we encourage rapid design iterations, and also the kind of manufacturing processes we use are like the 3D printing we use for all the thrusters and the upper stage engine, which is in our launch vehicle, which allows us to, what traditionally takes multiple months to build an engine can be brought out of the system in just 2 days, end to end. So with all these kinds of design and process related innovations, we are trying to reduce the cost of the bill of materials cost of the launch vehicle, thereby able to provide a low cost access to space in the future once we become operational. So coming back to the topic, the one key point what I want to address is basically why even a low cost access is required. I'm sure you must have gotten good idea about how to do it and the kind of approaches people are taking to enable or make the low cost launch access possible. One is making these design choices for the expendable launch vehicles. Other is, as SpaceX is doing, making things reusable so that we can drastically reduce the cost of space access. But the reason why low-cost space access is mandatory is, even though the share of launch industry in the overall launch space market, as you must have known, is not significant. In the $370 billion market, hardly less than 10 billion is the launch access market. But essentially, that is the key enabler of everything else. Without access to space, and with all the other industries will not be able to materialize and work it on. So making low-cost access to space possible will enable the industries which we cannot foresee now to be able to. There's a latent demand which for space-based solutions which is not getting seen or getting worked out now because the cost is prohibitively expensive. And making the cost of space access an order of magnitude less will unleash a latent demand that is unseen now, and the things the standard applications which we are all aware from space are Earth observation or the communication, IoT. The applications which we cannot foresee now will be possible a decade or two later once we drastically reduce the space access costs. Just like the inventor of the computers who could not even foresee why every home would need a computer in the future. We now at this juncture cannot even foresee the applications from space that will be possible a decade or two down the line. Yeah, that's pretty much what I want to comment on.
Thank you, Mr. Bharat, and good luck for your Vikram series of launch vehicles. We have now Mr. Rohan Ganapati. He is the founder director of Bellatrix Aerospace. They are mostly into propulsion as well as launch vehicle and working on green propulsion. Yes, Mr. Rohan, I would like to hear your comments on the topic, as well as, the clustering of engines is really, it's going, if you want to have mass production of engines and then go for clustering, maybe I would like to hear more on your green propulsion as well as clustering and your views on the topic. Over to Mr. Rohan. Yeah, please use.
Good afternoon, ladies and gentlemen. Dear Unikrishnan sir and gentlemen on the dais and friends and colleagues of the dais, thank you for having me. This is an interesting topic which I wanted to discuss, also to answer sir's question. But before, I would also like you all to ask this question for yourself. What is space transportation? So being a science fiction fan, it's all about, going deep into the solar system. And you see a topic here called, today's topic, a new paradigm. What is a new paradigm? Are we supposed to build technologies which travel at the speed of light? I don't know, maybe I want to do, but what advice we get from experts is, no, let us just sit down and look at what's practical. So what we've been doing so far is we are repackaging what is available and making it much more cost effective, right? And what is the need today to repackage things in terms of be it propulsion or space transportation? That's because globally the trend is what you're seeing is, a lot of private people are looking up to the sky. There's more demand from space. So the great inspiration from Vikram Sarabhai, who founded ISRO, he wanted to use space for the good of common man down here on Earth. Right? So now that's what more and more people, as you get into space, what is the one thing which was stopping everyone is the cost. Okay, the economies of scale was not making sense. So that's when we all started to think, what are the ways in which we can repackage the technology which has been mastered by people, be it from either from ISRO or the global space agencies. So at Bellatrix, we are electrifying space. We build electric propulsion systems. Just like there's a revolution on Earth for electric mobility, the same thing is happening in space, because you want to package more and more payload onto your satellite, because that's, end of the day, that's what gives you return on investment. But sadly, the rocket engines are eating up a lot of your space and fuel. So electric, it's the opposite. It requires just less fuel to do the job. And that's an area which we are working on. And also, Rajat, my colleague, spoke about space mobility and last mile connectivity. That's something very important, because see, now we don't just see as going to space and putting satellites in orbit, right? Now we are talking constellations of satellites. Each orbital slot is becoming a real estate in space. So how would you actually do that productively? So the answer is propulsion. You need push. So, and in-orbit mobility, to have the capability to deorbit once you near end of life, and also servicing in orbit, manufacturing in orbit. So these are not science fiction anymore, and these are turning into reality, and this is something which we are working on. To answer sir's question regarding clustering as well, now what we see is we are companies or small companies do not have the capability to produce mammoth engines like what Elon Musk might be doing or bigger space agencies might be doing. So what we intend to do is develop smaller engines and cluster them. So there are a lot of technological challenges, hurdles which come in way because each thruster doesn't produce the same amount of thrust. This is more critical problem for us in space because if you have 4 engines, and each are rated at say 1 Newton of thrust, and even if one produces little bit more, you have to spend more fuel to correct the error which that particular thruster produces. So to compensate for that error, you spend more fuel. So these are some of the challenges which we are currently facing and which needs correction. And another one is globally, you know about we are talking about climate change and we're talking about greener technologies. At Bellatrix, we are working on greener propellants because it is safe to use. You can just fill it at where you're manufacturing your satellite. And the byproducts are also very safe and it's not expensive to produce. And for the human spaceflight program, if you see, you don't want hydrazine to leak into the environmental control system, which affects the astronauts. So it has to be as safe as possible. It should not catch fire. So keeping these things in mind, we are focusing on research part of it. If you see today's topic, there's also a word research. So it's not just about repackaging, I would say, working with academia and ISRO. We are also one of the first startups which ISRO supported us to teach us how to build things for space so that they don't blow up in space. So that's something we learned from our friends in ISRO. But the future is exciting. It's not just about putting satellites in space. We're talking about mining on the moon because we as human species are dependent on natural resources for our survival, right? So let's stop damaging planet Earth, and there are resources outside, and we are building cost-effective technologies. So it's no longer science fiction, as I'm saying. So it's all about venturing deeper into space, just like you've seen on the Amazon series Expanse, right? So space transportation, just like our ancestors used sea routes, invented big ships to migrate to other continents, we are taking baby steps to actually in a good way to colonize space, and future is exciting in this domain, and I hope to see many of your next generation working in space with the technologies which we build today. Thank you for organizing this.
Thank you, Mr. Rohan. Good luck to all your efforts and dreams. Now, for the first, we have the final panelist, Mr. Tushar Jadhav. He is a co-founder of Manastu Space with a rich experience of DRDO. What is interesting is his area of interest is debris in space. We know that how he is going to make business out of debris is something which we would like to know. Debris is a menace. We all of us know because the man-made debris it's already, in fact, the low Earth orbit is becoming more cluttered because of so many constellations and all that satellites are there. So it becomes very difficult for, to make that satellites are not colliding with each other and you are safe. Yeah, over to Mr. Tushar. Please give your views on the topic what we are discussing today and your comments. Thank you.
Yes, sir. Thank you so much for this opportunity and interesting panel. Thank you, Rajat, Rohan, for expanding the definition of space transportation apart from, things happen till the launch vehicle separates, the satellite separates from the launch vehicle, and things happens after that. And that is the last mile is absolutely crucial as the constellation is playing a big role. And in all these discussions on satellites, there is one big elephant that no one is talking about is the debris. And then how to work with it. And then there is another word in the title which is a paradigm. So what are the ways in which we see this debris as well as the paradigm in a way to do a thing in a new way? So the answer lies in the word called sustainability. So can we have a space transportation which is more sustainable? And when I say sustainable, it's like a buzzword, but it is very powerful word. So it involves cost also. It involves something that is non-polluting also. It involves something that is safe also, and it will involve something that is, accessible to the last person also. So when we say the new paradigm in space transportation, and the people are working on building a new launch vehicle which are reusable, we are talking about. So new paradigm can we reuse the satellites also? Because cost of building a launch vehicle is coming down drastically, especially with the introduction of, if the Starship becomes reality, then that can go as high as say $100 to $500 per kg, which is like a geo moment for a space industry. And so what will that do is that will increase the number of satellites. So rather than increasing the satellites who will get dead in say maybe 3 years or 5 years, so can we have a new technologies like in-space refueling, in-space services, and then the deorbiting services as a new paradigm to support this satellite, so that you may not need that many satellites, and you save the space from the debris. So that is one aspect of answering the debris challenge. Basically, the debris challenge is a very multifaceted problem, and multiple factors needs to work together to do that. Then the second aspect is, there is a debris and it will be increasing somewhat the other way. How to save at least your own satellite and not let destroyed by any other debris or any other satellite, and not debris from your satellite let destroy any other satellite, so you don't get into any legal trouble. So for that we are envisioning a propulsion system which is agile, efficient and affordable with intelligence in it. So can we have like flight collision avoidance system that is there in aircraft? So can we have something similar in satellites also? We believe that will be the reality maybe say 5 to 10 years down the line, where when the numbers of satellites will start realizing it. So for that, the propulsion system with the intelligence is one thing that we are building, so that it can be an autonomous system. Another things of course is, because when we say space, and it is just the start, so we believe what currently the space industry is at the junction, what automobile industry was 100 years ago. Very small traffic on the road, so there was no significant problem. So we need to envision the space when we say sustainability from the next 50, 100 years down the line, and these debris problems and the sustainable space access becomes a very key. So the technologies, green propulsion, electric propulsion, the reusability, the robotics, and also the new, as Dhaka was mentioning, the robotics, the manufacturing in space. These are the assets that are coming in, but the sustainability, keeping in mind, is a way that we need to work with. And the another major part, this point comes in that we are not discussed, is how we can collaborate internationally to make this happen. So whose responsibility is, and hopefully the space policy will make it clear, and then all the friendly nations will work together to avoid that problem. So it's not just the technology problem, it's a policy problem that we need to work very actively with all the stakeholders. So coming to the enhancing the capabilities, the research part of it. So the major challenges that the startups and the industry is facing is the financial support. Everyone knows it. The talent is another area. Then the support from ISRO and the universities in developing the student satellite programs, giving the in-space is starting some technology, the courses, minors related to that, to the space. So that will definitely help in getting the talent that can, is ready to start delivering in the startup space industry. So the talent is access to the infrastructure through in-space and private consortium will definitely a way where, we can have the facilities which are shared, so that we don't need to, everyone doesn't need to invest into developing those facilities. And strong strategic, collaborations with startups, industry startups, government startup, as well as the corporate and the startup, we believe are the ways in which we can enhance the abilities of all the space industry that we are. And India plays we believe, as a geopolitically, as well as the cost-wise, economic-wise, geopolitic-wise, India is, especially in the last couple of years, India is sitting at a very, very strategic location with a very strategic advantage that, and with a very strong push from the minister side, the space transportation, space services is one of the areas that India can really make a contribution. And I think we are on the right track. A lot more needs to be done, but we are on the right track. Thank you so much.
Thank you, Mr. Tushar. So with that, we have heard all the panelists. We have few more minutes. If any of the panelists feel that some more points they want to discuss, just free, open to all. Otherwise, we will ask one or two questions from audience. Any questions from audience? We may be able to take one or two questions.
What is the, I'm Nagendra Rao, former director of LEOS, ISRO. What is the kind of transportation target what you are estimating for either the public sector or for the private sector? Cost per launch.
Yeah, that is what I was showing. Cost per launch is something for us right now it is close to something like $10,000 per kg. It is not the lowest, of course, because lowest happens because of this such introduction of such disruptive technologies into the launch vehicle technology. And we hope we also will have such things. Experiments are going on, and many startups are also trying their best. So with all these technologies, we will be able to further reduce the cost.
Hello, sir. My name is Anand. Is anybody working on human space travel in India, and can you give us some thoughts on it?
Yes, there is a program called Gaganyaan, and I happen to be the first founding director of Human Space Flight Center. It's in Bangalore. And the GSLV Mark III, which is going to be human rated, and the vehicle systems are all in final stage. We are into the hardware is getting realized. Astronauts have gone and come back. They have done some training in Russia on generic space, and now the Gaganyaan specific training is going on in the ad hoc at astronaut training center that is built in Bangalore. Engineering systems are getting realized, life support systems are getting realized. Many national institutions, industries are party to that, and the recovery part of it is being taken up by the Indian Navy with all the forces as part of them. So it's going on, and soon, maybe next year, we will have the first unmanned flight. But before the end of this year, we will demonstrate in-flight demonstration of the escape system, targeting for a manned flight maybe year after next.
Thank you.
Yeah.
Thank you, Mr. Chairman. As a visiting Australian, I'd be keen to hear from Rajat as to what he thinks, what support could be provided between the Indian and the Australian governments to enhance collaboration around transportation in space, given we are here as a partner country at the Bangalore Space Expo.
Yeah. Rajat, you are the right person to answer that question.
Thank you. I think from my perspective, India has a large heritage of launch vehicles and that direct-to-space access with the variety of launch vehicles available and new ones being developed. Australia has a very young space industry. And as we start to build in space last mile transportation solutions, I think there's a natural collaboration and combining launch vehicles that are being produced and are in plan to be operational in the next 3 to 5 years, working with small, medium businesses in Australia on how to help with those last mile delivery, whether that's deep space exploration, whether that's LEO, whether that's in orbit servicing. So I think there's a great opportunity for companies across both Australia and India working with private launch vehicles, but also public launch vehicles to sort of get customers the most reliable, cost-effective option.
Thank you, ladies and gentlemen. We are running out of time. All the panels will be anyway available. You can have the interactions later. I want to thank all the panelists for sticking on to the time. That is why we could complete on time. Over to the organizers. Thank you.